Good afternoon. Today I'm going to be proving the following proposition using mathematical induction for my discrete math class. And the proposition is 1 plus 3 plus 5 plus 2n minus 1 is equal to n squared for all integers n greater than 1. Okay, to go ahead and prove this, by mathematical induction, I have to first have my predicate ready. Okay, so this is going to be my predicate. Okay, it's going to be let P of n be logically equivalent to 1 plus 3 plus 5 plus 2n minus 1 is equal to n squared. Okay, once we have our predicate, we can form our basis. Okay, in this case, the basis is going to be show P of 2 holds. It's going to be 2 in this case and not 0 or 1 because right here we want our n to be greater than 1. So that's why we're going to be using 2, which is right after 1. Okay, so to go ahead and show that this holds, I must show that the left-hand side is equivalent or equal to the right-hand side. So I'm going to go ahead and show that in this following page. In this case, the left-hand side is going to be logically equivalent to 1 plus 2 times 2 minus 1, which simplifies out to be 3 plus 1, which is equal to 4. And on the right hand side is logically equivalent to 2 squared, because we're going to go ahead and plug in. Remember, we're going to plug in this 2 for our proposition, and 2 squared is equal to 4 as well. So therefore, P of 2 is true since 4 of 4 is equal to each other. Okay, so we're going to go ahead and move on to our inductive hypothesis. And in our inductive hypothesis, we're going to assume that P of k is true for some k greater than 1. Okay, in this case, we're going to assume that 1 plus 3 plus 5 plus 2k minus 1 is equal to k squared for some k in the set of positive integers where k is greater than 1. Okay, and so once we assume that, we can also go ahead and have our goal ready. Okay, where we must show that P of k plus 1 also holds. Or, in other terms, 1 plus 3 plus 5 plus 2k minus 1 plus 2 parentheses k plus 1 parentheses closed minus 1 is equal to parentheses k plus 1 parentheses closed squared. Now, as you can see here, for the following terms, I went ahead and replaced the regular k by k plus 1. Okay, as you can see here. Now, you might have noticed that this side right here is also being added here with all of this. And this is because this was where the k was by itself, not k plus 1. And so we have to include it as well because that's what comes before the k plus 1. And so I included this plus this right here to go ahead and show that, show our goal, basically. So now we have to prove this. Let me go ahead and move to the next page. Let me go ahead and add this up first. Okay, so remember we had this going on, okay? And I went ahead and simplified this down to 2k plus 2 minus 1 to make it easier on the eyes. Or, the whole thing, 1 plus 3 plus 5 plus 2k minus 1 plus 2k plus 2 minus 1 is equal to k plus 1 squared. Now, notice that 2k plus 2 minus 1 is actually 2k plus 1, okay? So we're going to go ahead and move on to our inductive step, or our proof, okay? And to prove this, again, we have to prove that the left side is equal to the right side, okay? Observe that on the left-hand side, this right here, or this right here, is actually replaced. We can replace it by k squared. And that's because of our inductive hypothesis, okay? Now, once we do that, okay, down here, you can see the k squared. And I went ahead and added the 2k minus 1 down here, which is actually, I'm sorry, not 2k minus 1. I added the 2k plus 1 down here, and I put it down here k squared plus 2k plus 1. And I went ahead and I removed the parentheses here, which is just k squared plus 2k plus 1. And notice that right here we can go ahead and factor this out, okay, to k plus 1 parentheses k plus 1 parentheses, okay, which is k plus 1 times k plus 1, which is actually k plus 1 squared. Okay, so if you haven't noticed, we just proved that the left hand side is k plus 1 squared. Okay, so we just proved that this is equal to, remember that this was the right hand side, this is equal to this. So basically we proved k plus 1. So let's go ahead and move to my last page, where we have the following, okay? And we can conclude this by saying, so P of k plus 1 does hold by the principle of mathematical induction. It follows that 1 plus 3 plus 5 plus 2n minus 1 is equal to n squared, okay? For all of n in the set of positive integers where n is greater than 1. And therefore we have proved our proposition that we wanted to prove. Thank you for watching.